So the first thing we're going to focus on in our examples is just to review how transformational graphing works with quadratics. I did mix it up a little bit here, and I'm asking you to graph f of x minus 1 minus 4. And I did this just so you can see a different way of how it might be presented to you on an SAT or in a different teacher's class. So the direction says f of x is x squared. Write the quadratic equation and graph it by using transformations. So what that means is that f means x squared. So the first thing I want you to do is to write down, well, what is the equation? So the equation f of x in this example is x minus 1 squared minus 4 from the previous chapter. And now I want you to go through and remember how to find the vertex. So remember, it's going to be the opposite of h once you factor anything out. There isn't anything to factor out, so it would just be 1, not negative 1, opposite of h. And then minus 4. The axis of symmetry, which is new this chapter, is x equals 1. You must have the x equals for it to get full credit on an assessment. And the reason is if you just write down 1, does that mean x-intercept, y-intercept, vertex? What is that? So you have to label it, that way I know what it is. We're going to find the y-intercept first because it is easier than the x-intercept and it's new, because remember, x-intercepts are simply the same thing we did when we solved. So y-intercept is f of 0. In fact, there are SATs and questions later in calculus where they just refer to the y-intercept as f of 0. So they are one and the same thing. So we're going to simplify this expression. So 0 minus 1 is negative 1, right? And you square that. And then you subtract 4. Please remember that anytime you square something, it is positive. So this will be 1 minus 4. So this comes out to negative 3. So the y-intercept, you want to label it correctly too. Don't say it's negative 3. It is 0, inputted 0, outputted negative 3. It's very important. In this chapter, since we've already learned how to do this before, the importance now is, did you write things correctly in their correct format? To find the x-intercept, you set the equation equal to 0. And this is universal. This is not just for quadratics or for just this chapter. In fact, absolute values, when you set them equal to 0, you're finding their x-intercepts. Later on, when we learn about other things, that's the same process. We're now going to reverse this using, solve this using reverse order of operations or GELMDAS. So we're going to add 4 since it's at the bottom of GELMDAS. All right, zero that out. Sorry, that doesn't zero out, my apologies. This does. So this is 0 plus 4 is 4. You can see how easy it is to make just a small boo-boo. Your brain just plays a trick on you. Please make sure that you're being careful. All right, so here we're going to take the square root. Make sure that when you take the square root in solving, you include a plus or minus. So this comes out to plus or minus 2. And this comes out to x minus 1. This means that I'm going to have two equations. So you might remember this all the way back to absolute value. You're going to have x minus 1 is equal to 2. And you're going to have x minus 1 is equal to negative 2. Here you're going to add 1 to both sides, and you get 3. Here you're going to add 1 to both sides, and you're going to get negative 1. Keep in mind, on an assessment, these would be marked off by a point. They are x-intercepts now. So this is 3, 0, and this is negative 1, 0. That's very important moving from this point on in Algebra 2 to write things in the correct format. So let's put all this together. Let's take a look at the graph. So when we take a look at the graph, I went ahead and graphed the axis of symmetry using a line. And so that line is x equals 1. And now we're going to graph the vertex at 1, negative 4. My x-intercepts are right here at 3, 0, and negative 1, 0. Okay, notice that symmetry, that they're the same distance, 1, 2, 3. Right, the same distance away on each side. Actually, I graphed that one incorrectly. It's at 4, so 1, 2, 3 is there, negative 1, 0 is there, and that's why the axis of symmetry is so important, and it helps check your work, as you can just see that happen. And then here, the y-intercept is 0, negative 3, which would be here. Now, why did we do it this way? The interesting thing is, if we did this problem from the previous chapter, it would come up to the exact same answer. So I'll graph it again using a different color, and you can see what I mean. So if I did this with the previous chapter, I would have started at 1, -4 as my vertex, and I would have gone over 1, square 1 is 1, -1, square 1 is 1, over 2, square 2 is 4 up, left 2, -2, square 2, -2 is 4. Notice they're all the same points. And so this is really supposed to just help you make those correlations as you're learning it. All right, so let's take a look now at the next problem. Very similar, but there will be a stretch, which we'll look at that as well from our previous chapter. So again, a little disorienting at first because it asks you to do f of x minus 8. Now, what is that? Where is that? Remember, f of x is x squared, so the first thing you do is write down the equation. So the equation for this one is f of x is equal to 2x squared minus 8. Please keep in mind that this parentheses is closed, so there is no h, there's only a k. So the vertex will be 0, and I always tell my students, no parentheses, no h. It's really important to remember that. There's no parentheses, so that means that 8 has to be a k. That means our axis of symmetry is going to be x equals 0. Make sure you have the x equals. And to find the y-intercept, we're going to find f of 0 by plugging 0 in. And this is an interesting problem because when I plug 0 in, when there is no h, I actually have it in standard form, which is really interesting, that when h is missing, standard and vertex form are exactly the same. Because this will cancel. 0 squared times 2 is 0, and then minus 8. So f of 0 is -8. Please keep in mind if you ever see this on an assessment, especially in SAT, this means y-intercept. But we're going to write it like this. I plugged in 0, and I outputted -8. I want it in the point format in this course. So the x-intercept is to set the problem equal to 0 as opposed to plugging it in. I'm going to use, well, what method makes sense? There's no bx term, so I'm going to use the square root method for this problem. I'm going to add 8 on both sides. Just remember that everything you've learned in this chapter, it's all consistent. There's nothing really new. It's just how do I use the information I learned. This zeroes out or cancels out. Here I'm going to, I did the bottom part of reverse Gelmdas, so I'm now going to divide by 2, giving me 4. And this, of course, will inverse. Here I'm going to take the square root, and when you take the square root, you need to put a plus or minus on it. So we have plus or minus 2 is equal to x, and I did this on purpose so you could see the difference. Here we had an equation to solve, but here there's nothing on the inside, so my x-intercepts are in fact just going to be -2, 0, and 2, 0. It is important to not leave it like this. This is not the answer when I graph. This is. All right, let's take a look at the graph. In this case, we have an 8, so we're going to need to go by 2's. I put the axis of symmetry here at x equals 0. It is, in fact, the y-axis, which is a little bit interesting. That the when you have x equals 0, that's going to be the y-axis. So now what we're going to do is we're going to graph the other pieces of this. The vertex is at 0, -8, so 0, -8, and that is in fact the y-intercept because when we found that, yep, the vertex and the y-intercept are the same, and you can see that immediately when you graph it. And then we have our x-intercepts at -2, 0, and 2, 0, and that would be it. I need to go back and graph this one. Don't ever leave the dots like that. You're always going to want to go ahead and graph it. And then here we can graph this one, and then we'll take a look at what it looks like, right? So from the previous chapter. So if I looked at it from the previous chapter, our vertex would obviously be at 0, -8. That part didn't change. The question is, how do I get to this dot? Well, we had a vertical stretch of 2, and we're going by 2's. So over here, we would go 1, which is half a box, and then up 1 multiplied by 2. It's right there. Here we'd have -1 multiplied by 2. It'd be there. Oops, a little bit off. And then here's the dot that actually makes our x-intercept, so let's pay close attention to this one. I would go over 2. I would square that and get 4, but we had a 2 as a lead coefficient, So we have 2 from our squaring, and that becomes squared, so we have 4, and then we multiply times 2, so we end up going up 8. So over 2, square is 4, multiply times 2, 8 above the vertex. Same thing here, negative 2 squared is 4, and then multiplied by the stretch goes there. So it all works out perfectly from the previous chapter.